Well, hi everyone. We have this practice test here, and there are various parts. First page, we're finding inverses of functions. Second page, we've got three problems where we have to determine whether two functions are inverses. We have a question here that what are the one-to-one functions? We'll discuss what those are. And we're going to graph a couple of square root functions. Actually three, and then we have three graphs that are made, and these look like inequalities because of the shading that we have to come up with that inequality. So, and this will look very similar to the format you'll be taking on the real test. So, let's go through that. The finding the inverse of f of x equals 3x plus 1. Just remember the steps. Step 1, we're going to put y in for f of x. Step 2, we're going to switch x and y in the equation. Step 3, with that switch, we're going to solve for y. And in step 4, put the inverse function notation. Put this notation in for y. We'll take the y out and put this in. All right, so that's our step-by-step process when we're doing this. So what did I say first? Y goes where f of x was, 3x plus 1. And then I switch those two around, and I have x where y was and y where x was. And then I solve for y. So I'm going to subtract 1 from both sides, and I have x minus 1 here. And that canceled, so that's 3y. And I divide by 3. And so I have, I'm going to put the y over here. The 3's cancel. That's y equals x minus 1 over 3. So the inverse function of f is x minus 1 over 3. All right. I'm going to follow the same steps for this one. I have y equals x squared minus 2. I'm going to switch the x and the y around. I'm going to add 2 to both sides. I have x plus 2 equals y squared. And then I'm going to take the square root to cancel out with the square. And when I take the square root, I have a positive and a negative square root of x plus 2. So I have, put the y over here again. Write it first, equals plus or minus the square root of x plus 2. I'm going to go ahead and write that notation, although I'm not crazy about that notation for this problem, because this is not an inverse function. This is two separate functions. You have a positive square root of x plus 2, and you have a negative square root of x plus 2. And then, for this last one, put y where f of x is. I have x plus 4 over 2. And then I'm going to switch and put x equals y plus 4 over 2. I'm going to multiply both sides by 2 because I'm solving for y now. And I got y plus 4. I got 2x here. I'll subtract 4. And I've got 2x minus 4 equals y, which is the same as y equals 2x minus 4. And then my final answer, I'll use inverse notation. I do like it for this one, though. That's 2x minus 4. All right. Now, if you need to determine, you have a pair, you have f of x and g of x, you need to show that f of g of x, the composite function, is equal to x, and you need to show that g of f of x is also equal to x. So let's get started on that. And if it checks off on both those cases, then they are inverses. So let me find f of g of x for this first one. And that's f of 1/4 x plus 3. Took the g of x out. This g of x was here. I'll just put what it's equal to here. And now in the f function, I'm going to take 4, take the x out, and put 1/4 x plus 3, and then the minus 6 out here. This is 4x minus 6 up here, but now we're finding with this in place of the x. Let's distribute. 4 times 1/4 x is x. 4 times 3, that's 12, and then minus 6. And then 12 minus 6 is positive 6. Okay, this is not equal to x. So f and g here are not inverses. It needs to be x. And it's just not the case there. So let's try this one. F of g of x is equal to, and if I find one doesn't work, I don't need to do the other. All right. I looked at that. That looks like two separate words. Let me get those a little closer to each other. That's one word. All right. F of g of x. That's f of the square root of x minus 1. Let's see if this one works for being inverses. So I'm going to put this in where x was here. So, and I would recommend always using parentheses where the x was. Do that substitution, then plus 1. Right now, square root and a square cancel each other out. So that is just x minus 1, and then plus 1. X minus 1 plus 1 does equal x. Okay, so we've checked with f of g of x. Let's check with g of f of x. That's g of x squared plus 1. So we're going to take the x out, put x squared plus 1 in its place, and then I have this minus 1. And x squared plus 1 minus 1 is x squared. And the square root of x squared is x. That checks. F and g, in this case, when they're defined like this, are inverses. All right. And let's try it one more time. We're going to find f of g of x. That's f of 9x squared. Nope. That's what f of x equals. That's f of 3 radical x. So I'm going to take 9, and then I'm going to take the x out, put 3 radical x in, and square that. And that looks like 9 times 9x. And boy, that looks like 81x to me. 3 squared, square root of x squared is x. Okay. That is not equal to x. So we have two of them here that were not in, two pairs that were not inverses. So f and g are not inverses. Okay. Oops. All right. Now, you need to circle the one-to-one functions here. I think I'll probably have a question like this. I may give you a handout that has the actual graphs on it, so you don't have to spend the time graphing it. But I am going to draw these graphs. And I need the square root of 9x minus 4. Okay, if they are 1 to 1, that means their inverse is a function. So it needs to pass the horizontal line test. And if it passes the horizontal line test, then we're going to say yes to 1 to 1. We're going to circle those. So square root of 9x minus 4 plus 5. I'm going to look at that graph. Alright, and if I expand it out, this is a square root function. It's going to go like this, on and on. And I'm going to circle it. It'll pass the horizontal line test because it's going to continually go like this from that starting point, and any horizontal line is only going to hit it once. Alright, I'm going to clear that one out. Graph the next one. 2x to the third minus 3x squared minus x plus 1. Alright, see how it goes up, comes down. We've seen functions like this in the last test, but this will not pass the horizontal line test. It hits it 1, 2, 3. This horizontal line hits it 3 times. The x-axis hits it 3 times. So I'm not going to do that. It has an inverse, but the inverse is not a function. Okay. Let's go y equals negative 0.5 x squared. Graph that. Not passing the horizontal line test. The inverse is not a function. Alright, let's do 0.4 x to the third. Graph that. Alright, now this one, it goes and then kind of doesn't flatten out completely. It's always increasing. But at the origin, you're still only going to hit that. Hit that once. So I am going to put on this one, I'm going to circle that one. And I think I know this one. It's negative slope. This one's going to be going like this. It will pass the horizontal line test, but we'll look at it anyway. Negative 3x plus 2. That is passing the horizontal line test. So these are the 3 I'm circling here. Alright. We're going to graph the domain and range, or graph the function, sorry, and then give the domain and range. Alright. The first thing we'll do on here is we'll deal with the shift. And then we're going to make the table. I'm going to go ahead and just make it right now. 1, 1, 4, 2, 9, 3. This is x and square root of x. We'll deal with those 3 values. And then we'll talk about domain and range after that. But the shift from the origin of this one is 2 right. Remember, with that minus 2, we got to go right, and 3 down. With this minus 3 on the outside, we'll go down. 2 right, 3 down. So here's our starting point. So you graph the starting point, and then from the starting point, you use your table to get the rest of it. And then you deal with the domain and range. So from my starting point, this is right, which is the x, and the y, this is up. Okay, so I go right up, right 1, up 1. From the starting point, always not from here, the starting point, go 1, 2, 3, 4 right, up 2, and then go over. I don't have enough room to go right 9, so I'm just going to stick with this, and it's always increasing, so I'm going to keep it increasing. And I've got my graph. The domain looks like 2 and higher. So I'm going to do this, 2 to infinity. The range, to me, it looks like, here's the low point, is -3 to infinity. Okay. Number 9. Okay, starting point. I'll just do SP for starting point. I'm going to go left 1 and up 4. Left 1, whoops, left's this way. Left 1, up 1, 2, 3, 4 is right here. So I have my starting point. And then my table, I'm going to do it again. X, Y, 1, 1, 4, 2, 9, 3. Remember, this is square root of x. Now, we actually have a -1/2, and you don't need to consider that until now. -1/2 times square root of x is right here. -1/2 times 1 is -1/2. -1/2 times 2 is -1. -1/2 times 3 is -1 1/2. Or 0.5 if you prefer. So, I'm going to cross this out because I don't need this. I need this. This is my right, and this is my up. So I'll go 1, but I'm going to go up -1/2, which means I'm going down a half unit. I'm going to go right 4 and down 1. 1, 2, 3, 4, down 1. Right 9 and down 1 1/2. 2, 3, 4, 5, 6, 7, 8, 9, down 1 1/2. That's right here. Okay. So this is kind of going like this. Domain. That's x from -1 and higher. The range actually keeps going down. It starts at the high point. So the high point is 4. It has no bound on the low point. So -infinity to 4 is the range there. Okay. This one. Oh my goodness. Okay, I didn't write a different problem there. Wonder what I was going to write. This gives me pause to wonder if I... Alright, that is the exact same one I did. Let me just... I'm going to put a new problem in. Let's do y equals 3 times the square root of x minus 1 minus 5. Let's see what that looks like. Alright, so for the starting point from the origin, we're going to go right 1 and down 5. Okay. Right 1. Oops. That's right. And down 5. 1, 2, 3, 4, 5. Here we go. Right 1, down 5. I'm going to do my table again. This is square root of x. 1, 1, 4, 2, 9, 3. And then I'm going to do 3 times square root of x, and that's 3 here. 1 times 3, 2 times 3 is 6, 3 times 3 is 9. I'm not going to pay any attention to this. This is my right movement from the starting point, and this is my up movement from the starting point. Right 1, up 1, 2, 3. Right 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. and write 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the way this one's going. Okay, domain. Oops, this way. Domain is 1 to infinity. That's what's happening x-wise. Range, it starts down here and just keeps going up. So the low part is -5, the high part is infinity. All right, now it's time to look at graphs. I would always start with y. Shading above is greater. Solid line is or equal to. I'm going to write the starting point, 1, 2. I went 2 right, so I'm going to put x minus 2, and I went 3 up. And go up 3. And I'm looking at this, and I'm seeing, you know, in our table, the first is 1, 1, over 1, up 1. If that's the case, then we got what we need. We could put a 1 here, but that is close to the parent function. We're just shifting it. All right, now number 12. I'm going to put y. This time I'm going to go less. It's less here. When it's above, it's greater. Y is less than. It's dotted, so I'm not going to put or equal to. I'm going to put a square root here. Okay. And I went, looks like I'm going right 1, up 1, just like that first part in the table. But, okay, actually we shifted it 1 unit to the left. So I'm going to go x plus 1 here. And I shifted it 1, 2, 3 units down. So I'll go minus 3 here. Okay. This one is less. So let's go y is less than, and it's dotted, so I'm not going to change that. Now, there is a difference here. Now I've shifted it 1, 2 to the right. So I'm going to go x minus 2 and shift it 1, 2, 3 down. So go minus 3 here. That's the starting point right there. And the only difference is instead of going right 1 and up 1, we went right 1 and down 1. So that's a -1 there. Or if you prefer not to write the -1, you can write this. Okay, there you go, guys.